Hey guys, sorry. So something happened with the last video. I'm not exactly sure, so I need to re-record this. Um, this video is for balancing equations. Some of you expressed, Misty, I'm still having trouble visualizing this, grasping this. So I found this really awesome interactive program. I'm going to embed it on my e-class, which is going to be really interesting since apparently I can't even work YouTube sometimes for me to try to embed it in my e-class so you guys can click on it and do the interactive game part. So there's an introduction part that we're going to go over, and then I'm going to show you the intro to the game. So that way you guys just know what you're doing and you guys can play with that and visually understand balancing equations. So here we go. All right. So when we start off, we are going to start trying to make ammonia. So we have nitrogen plus hydrogen that produces ammonia, NH3. Now, remember that nitrogen and hydrogen are both diatomic, meaning that when they are by themselves, when they're just the elements themselves, come in twos, like those identical twins attached at the hip situation that we used examples in class. So now I'm going to add one of each. The reason for that is you have to have something to be able to have your reaction. So blue dots represent nitrogen and white dots represent hydrogen. So you can visually see that nitrogen are stuck together. There's two of them together. They come in a cute little pair together. And I only have one of them, but I have two nitrogen. Now, hydrogen, even though I have one coefficient, I still have two attached together. When they form ammonia, they're able to break apart and form new bonds and form one nitrogen and three hydrogen bonded together. I still only end up with one ammonia. So, in order to balance this, you need to look at it and say, okay, who do I need? In this case, I definitely need another nitrogen on my product side. So I'm going to go ahead and increase him. But every time I increased him, I also increased oxygen. So I no longer have just one nitrogen. I have two nitrogen. And I no longer just have three hydrogen. I have six. Now, you guys, when you are adding these together, that is wrong thinking. It's not 2 plus 3 equaling 5, but it's 2 times 3 equaling 6. 1, 2, 3, 4, 5, 6. So I have 6 hydrogen. Now, let's look over at the reactant. Remember, it's like a game. You're going back and forth, checking to see if they're balanced. Now, when I increase hydrogen, I add 2 more, but only one coefficient. So now I have 2 coefficients, but 4 hydrogen total. But that still doesn't give me 6, where there's 6 hydrogen over here and 4 on my reactants. So I'm going to increase it one more time, and now he's balanced. I have 6 hydrogen on my reactant side, 6 hydrogen on my product side. And I still have 2 nitrogen on my reactant side. And because I increased him, my product, I have 2 nitrogen. All right, let's go to combustion of methane. So you have methane, CH4, plus oxygen. Now remember, oxygen is one of those diatomics too. Then it produces CO2, which is carbon dioxide. Remember, he is a covalent bond, so that's why you have the Greek subscript prefixes. And then you have H2O, your water. So I'm going to add one of each. So now, the gray ones are for carbon, and the white ones are hydrogen. Red ones are oxygen. You'll notice that on your product side, that CO2, carbon dioxide, and water, H2O, both have oxygen. So this can be a little tricky when you're going back and forth because you have to take the whole side into considering for how many oxygens that you have. So because I have 3 and 2, they're unbalanced. They're uneven. So let's go ahead and increase my water. Now, I happen to now have the same amount of hydrogen, 1, 2, 3, 4, as my reactants, 1, 2, 3, 4. But I'm still uneven with my oxygens because I have 1, 2, 3, 4 red balls on this side, and I have 2 over here. So when I increase my oxygen, I now have 4 oxygen, 1 carbon on each side, and 4 hydrogen, making my chemical equation balanced. All right, separate water. So H2O produces hydrogen and oxygen. Please remember that both hydrogen and oxygen are both diatomic. So I'm going to add one of each so that we can visually see it. So I have 1 red oxygen on my reactant side, and I have 2 red oxygen on my product side. Then I have 2 hydrogen on my reactants and 2 hydrogen on my product. So I need to increase the hydrogen. But because I increased them to match my oxygen, my O's, my red balls here, I no longer have just 2 hydrogen. I have 4 because 2 times 2 is 4, giving me 4 hydrogen. So I come back over here and I increase my hydrogen as well. So now he has 4 hydrogen, 2 oxygen, where my products and my reactants are equal. All right. Whoop, that was way too far. Sorry. All right. So the game side, there is a whole game with 3 different levels, 5 problems each that you can do to play back and forth to visually understand the chemical balancing. Again, this is not a video that's for homework. This is just for you to visually grasp what's going on. I'm going to go ahead right now and get on eClass and try to embed the program into eClass. I'll put it into the news section so you guys can definitely get that. Worst case scenario, I'll paste and copy over the link, and that way you guys can click on it and then go to the site. So yeah, I hope you guys have a great day, and I'm going to do some more videos later on tonight. Bye.